gentlemen, welcome to live stream number 138. My name is Lars Christensen, and thank you so much for joining today's live stream. Still a little bit under the weather here, struggling a little bit, but it's not going to stop us from doing a live stream. Today's topic is what is different with Fusion 360, and then we're going to talk a little bit about what does people mean when they're talking about design intent. So I'm going to do a little bit of a warning right up front here. If you came today, if you're a pretty advanced Fusion 360 user, then you maybe don't watch these live streams anyways. But if you're pretty advanced and you're looking for some cool tips and tricks inside of Fusion, that's not going to be today's topic. Today, like I said earlier, I want to do a better job answering your guys' direct questions. My email is down in the description area. And one of the questions that I've gotten quite a bit recently from people have been, what is really different with Fusion 360 versus some of the other products out there? We have Inventor, and I have used SolidWorks and other products. Now, I always, when I've answered these people, I've always said, hey, I got to be totally biased. I work for Autodesk, right? I work for Autodesk. I got to make sure. Though that here on the channel, my opinions are my own. I got to say that too. Don't go ahead and sue me. I work for Autodesk. I'm pretty far down on the org chart. So, anything I say should be bared with a grain of salt. But it's still a good question. What is different with Fusion 360 compared to other CAM products? What does the whole thing mean? And I want to give you my 2 cents. And then one guy asked a question about when somebody says design intent, what the heck does that mean? So that's all the things that I'm just going to talk about for the next 15, 20 minutes or so. So let's jump in here and being inside of Fusion 360. Fusion 360 is a fairly new product. And I say fairly, right? It's 4 or 5 years old. But Fusion 360 tries to do something a little bit different than, for example, Inventor or SolidWorks, or there's other products out there. Siemens has NX, PTC. What Fusion tried to do is to do 2 things. Well, more than 2 things, but 2 things. One thing is to try to combine some of the workspaces that people are normally dealing within to get a product out versus, for example, Inventor that is more of, I would say, an engineering tool. So when Inventor came out in the early 2000s, what is a long time ago, and it was kind of like, an engineering piece of software. Back then, if you, in the early 2000s, if you were talking about modeling something up, it was Inventor or SolidWorks. If you were trying to make product, I'm in the northeast of the United States, Mastercam was another product you would go to. So you would kind of jump around. So inside of Fusion, the idea of having these different workspaces is to kind of combining those different tools into one environment. So inside of Fusion, you have the model environment, you have a couple of the other ones, sheet metal patch, you have the sculpting, but then you also have the CAM right in here where you can apply the toolpath to. So really Fusion is kind of like a fused together, how about that? Fused together of different workspaces to try to make one. So that's one thing I just want to kind of I think personally, and this is just Lars talking, this is not, I am not, very, like I said, I work for Autodesk, that's important, but I'm not up there. But it's fused together of different kind of workspaces. The other thing is taking advantage of is the cloud, right? So, by the way, that also, some people ask me, is Fusion going to replace Inventor? No, at least not what I'm aware of. That's not the idea. The idea is that Inventor is a very stable product that's been around for many, many years. It's very good at what it's doing. It's a great engineering piece of software, very strong. Fusion is, like I said, trying to put different workspaces together and then utilizing, for example, the cloud. So if you're doing like ITAR type of work where you can never be on the cloud, then Fusion is not really the tool, right? Where Inventor, perfect for that. And by the way, if you're looking at Autodesk, AutoCAD is still out there. I mean, when Inventor came on board, everybody was asking if that was going to replace AutoCAD, but here we are in 2018, and AutoCAD is still there, Inventor is still there, and Fusion is here. So what we are doing inside of Fusion is utilizing the cloud. So with Fusion, if you go in and look here, here's all the models we've been doing on the live stream. Like I said yesterday, if you ever want to get any of these models, I try to do a good job saving them. Just send me an email and I'll send you a link to them. So that's one of the neat things about being inside of Fusion, is that we're saving locally on our computer, but also to the cloud. So if somebody reached out to me and like, hey, I really like that skeleton live stream you did, I can right click on this and I can say share public link. That will give me a URL where you can now download it. So you're downloading it from the web versus older CAD software where you were working just on one big powerful machine, and if you had to save a file, you would have to bring it, still locally. You'd have to maybe attach it into an email. By the way, now you are going on the cloud anyways, right? But that's another talk. And send it to a customer as an attachment or somewhere else. So this is one of the neat things about being on the cloud. And the other thing that is really neat about this whole cloud thing, in my opinion, many people have asked me questions about, can I install more than one seat of Fusion? And that's the whole, can I call it old mentality, right? Like when we used to do, and this goes back to Autodesk too, with Inventor and AutoCAD, that you installed it locally and you bought one seat and you can install that locally on one machine. With Fusion, you can install Fusion on as many machines as you want. There's literally no limit. It is your login when you're going to that machine, you're logging in. That gives you the access to your library with all your parts. So if I log in on your laptop with my computer with my ID, all these files that you see over here would be immediately available to me because it is the cloud that is using that. We're using the cloud for other things too. You can use it to solve simulation data, renderings, and things like that. So Fusion is just kind of like, I will say, the new kind of entry into CAD. So that's all Autodesk is trying to do. They're not trying to replace Inventor. It's literally just trying to add a new program with new functionalities. Last thing before I think we're going to start talking about design intent, where we're actually going to go ahead and model something on the screen. And that is price. That's another thing that people are asking me about. So Fusion 360, so somebody left a comment the other day, said, I can't wait till Autodesk decides to start charging as much for Fusion as the older type of CAD software that is a lot more expensive. Well, the only thing I can say to you is that I have worked for Autodesk for 4 years, and Fusion have been out for 4 or 5. The pricing model hasn't changed, and it doesn't really make, if you're looking at it at the point that Fusion is not there to replace Inventor, it's just new technology trying to build upon a new platform, trying to do with the cloud and the fused together workspaces. Using an old pricing model doesn't really make much sense either, right? So pricing is different with Fusion because it's a different type of product in a different time. So there was just an increase to the price of Fusion. So Fusion is still there's a startup license, startup/hobbyist, that is free if you make less than $100,000 or equal wherever you are in the world. And above that, It used to be $300 a year. Now it's $310. Okay, so yes, it was just increased by $10. But I think the reason I'm bringing that up is I think that that makes the point of the pricing model, that it's not Autodesk intent of suddenly flick a switch, at least again to what my knowledge is, to just suddenly charge what, you know, CAD cost in 1988, right? Doesn't make any sense. And there's a second tier that is the ultimate, that used to be $1,500. That is now $1,535. So it's like a 2% increase. I think what is pretty common that, you know, you had a price increase for the last 4 years of 2%, going from $300 a year to $310 a year. I think most of us, you know, that shouldn't make anybody you let me know. So I want to make, and then of course I should say it's free for all schools, educators, students, and all that stuff too. If you're making less than $100,000 a year, yes, you can still use Fusion 360. Just go to Fusion 360, download the trial, and I'm talking now, today is March 29, 2018. Things can change, right? But I just hope that answered the question that people are like, what is the difference between Fusion versus the other ones? 11 minutes was maybe too long to talk about this, but at least here's my perspective of it. I don't want, this channel here is to add more value to you. That's what I'm trying to do. So I hope that this was useful. Okay, let's talk a little bit about design intent. Question here. $310 per account. Yes. So one seat or whatever you want to call it. Yes. And I don't even know, man, about like if you're buying 10 seats. I don't know how that works. I'm not in sales. If there's discount and stuff like that, I couldn't even go. I don't even want to go there. I just hope that this, at least for some of you guys who are kind of like trying to figuring out what is Fusion 360, especially if you're using Inventor or another product, like, you know, is this going to be the end of that? And definitely not. Okay. Enough of that. Let's talk about design intent. That's another good questions. When people say design intent, what the heck do they mean by design intent? And it can probably mean a million different things to different people. But I think it comes down to what's going to happen with the part when it's done inside of Fusion 360. So I want to show you 3 ways to model up something inside of Fusion 360, but get to the same result. And then maybe we can talk a little bit about what we mean about that. So if I go in here and I create a new sketch, I'm just going to sketch on this side plane and draw a line, because that's the best thing here. Draw a line ahead here. Let me make this one 100. Like that there. And go up. Let's make this one 50. Well, I should just keep on sketching, actually. I'll just go ahead and sketch. And then we dimension it in the end. There we go. Let's throw some constraints and dimensions on this. So we're going to make this one 15. Let's make this one 15. And this one 50. And this one 25. That's good. This one 25. And let's make this one 35. Okay. And then I can see this one is still blue. If I drag the corner, I can see I can move that. So I probably just need a horizontal relationship on there. And now this sketch is now fully defined. Let's revolve that around this center line. Okay, here is our part. I don't know what you want to call this. A sketch and a feature, and we have a part. Ba-ba-ding, ba-da-bam. Great. Now let's go ahead and create this part a little bit different. What if we went ahead and let's do it all in, let's create a new part. That's maybe easier. Okay, new part. Let's draw here. Let's do a circle. And let's make this circle here 100 in diameter. And press pull. Let's make it 15. Do a new sketch. C for circle. This one here is going to be 50. Press pull. And this one's going to be 50. C for circle. Start a circle there. This one's going to be 102. And hit Q. And that's going to be 15. I think you have figured out what I'm getting at here, right? Two different ways to model up the same thing. I gotta do math suddenly. 45 minutes, that's, well, now I'm drawing a complete blank. So if that's 25, that was 50, so this is gonna be 35 maybe? We're gonna leave it at 35. And this here is gonna be, I should have practiced, huh? This is gonna be, well, let's just make it 50. I love when I'm struggling. 30, that's just 20. 20, I got it. I couldn't make the math. So what we have is two parts. We have this part, and we have this part. Same part. Actually, I think that maybe I got that diameter wrong in here. It's probably only be 25, actually. Two parts, same, two model up in two different ways. Same kind of like principle. I'm gonna do it one more time because I'm gonna show you one of my favorite ways to model up. Call this the manufacturing. If you're in a manufacturing way like I am, start out with the raw blank. So let's make this one 100 and Q. So this is kind of like the raw piece of stock of this one, right? And then we could go in and start removing that like you would, for example, with a lathe. So let's go in here and start a sketch here. And we can actually use like 2-point rectangle for something like this. We can draw two rectangles like that there. And then we can dimension those. So this one here is going to be 50. And it's going to be 15 from the back edge, and this one here is gonna be from here is gonna be 35, and how deep was this? 25. So we're gonna do P for project. Get that point in there. And let's do this to this. Can't do that. This is what I get when I don't practice. Oh. Horizontal from here to here. That should work. Horizontal from there to there. That should work. And this one here. So here. What did I decide that was 30? And it's funny when I don't practice these things, how I get myself in trouble all the time. It's kind of cute. I'm almost done. Okay. Did I ever? Yeah, it should be the same. So now we can do revolve again, and this time we're going to do cuts. So this is going to be the profile, this is going to be the profile, and the X is going to be this one here. Okay, that's not the same. That's definitely not the same. See that thickness? Ugh. So if that was supposed to be, let's delete this one. Make it a little bit easier on ourselves. That was supposed to be 15. There we go. Are they now the same? I think now they're the same. Okay. So this was the manufacturing approach. All right, I'm getting there. So I wanted to show you this 3 different way of modeling up the same part, and this is where design intent, in my opinion, kind of like comes in, because if you're looking at the 3 different ways, let's go back to the first one. This is clearly, in my opinion, the most efficient, right? One feature, one sketch versus all these features and sketches, and this one here that turned out to be maybe a little bit harder. But if you go in and you look at this sketch, there is a lot going on in here, and you could actually start just within this sketch to start saying, well, if we know that these 2 pieces here will always be 15, we don't need to have 2 dimensions. Same thing with these 2 should always be 25. So if we could delete this 15, and we could say instead we're going to use an equal constraint and say this line and this line are equal, right? And the same thing with the 25. If you're looking at the height of here, if I delete this 25, now this could be tall, and I could do say that I want this line and this line to be collinear, and I will have eliminated 2 dimensions on the part. My point is, design intent normally means what you're going to end up with, what you're going to struggle with. This is probably the most efficient CAD way to do something, but you can also end up with a sketch that can be extremely hard to kind of like figuring out. There's a lot of dimensions in here. If somebody else got to go in and model or edit your part later on, it could be confusing. You just saw how we had extra dimensions in there and stuff like that. The layer cake approach, or if you gamble in Vegas, the stacking chips approach here, by kind of like creating these different ones, that's many times an easier way to kind of like model things up, because you're kind of like breaking your model into different sections. And if somebody had to go in and modify this design, they could look at it at the different sections, right? Like literally, if we scroll back here, then that little tip goes away. So this is almost could be easier to go in and modify to build it up like this. And many times when you're learning CAD, this is the first way you're starting out, that you kind of like build it layer by layer. And then the last approach here, what I call the manufacturing approach, because we started out with our raw piece of stock, and then we went, in this case, over on the lathe, made a couple of cuts, and cut this away. Now, this one here could be maybe a little bit harder to modify specifically than the layer cake approach maybe is. But if you're starting out looking at this part here, if you are in a manufacturing way, it might be an easier way to approach your part. So when people ask you, what is the design intent? Well, then kind of like try to think about where you're gonna end up. So I would say that if you have somebody else gonna work with your model, the layer cake might be the easiest way to kind of like break it down, though that you're ending up with more features like that. I hope that was a good way to kind of like show that you can model the same part up in different fashions. And when people are talking about the design intent, it's kind of like you still got to end up with the right part in the end, right? It's more about how you got there. I hope that was useful. I hope this was useful. Like I said, I'm trying to do a little bit better job on answering when you guys send me the emails, answer your specific questions. I hope this was okay. Again, make sure I work for Autodesk. You should definitely not take my opinions about what Fusion 360. I think Fusion 360 is awesome, of course, right? You should definitely not use your own best judgment for whatever you need. But I hope that my explanation in the beginning made sense on kind of like where Fusion 360 is, at least in my opinion, versus a program like Inventor. All right, guys. I'm gonna end it there. Hopefully tomorrow my voice is doing a little bit better. Really appreciate you taking time. I'm gonna do what I normally do. I am gonna end the recording. So if you're watching the recording, thank you so much for taking the time to watch this. If you are in the live stream, I'm gonna jump in and say hi to everybody. Take care, folks.